I'm Sukriti from the Vandan Asankhya project, and we have Nirav Atre with us here today. Nirav is pursuing a PhD under Dr. Justine Sherry at the Carnegie Mellon University. He was a software engineering intern at Intel Corporation and has worked at Google with teams like the Android Treble team and the Android Nearby team. In addition to graduating with high honors in computer engineering at the University of Toronto, Nirav has won over 4 distinguished awards and fellowships like the NSERC University of Toronto Excellence Award and CNIB Prize. He was also a summer research fellow and summer intern under Professor Jonathan Rose at the University of Toronto. So, getting selected as a PhD student under Dr. Justine Sherry at a Tier 1 university like Carnegie Mellon University is an outstanding feat. What motivated you to do your PhD? And which area of computer science do you wish to work on?
Oh, thank you. So while in undergrad, I was always kind of strongly inclined to pursue academic research, despite not being entirely sure what that entailed. But I was pretty fortunate in that I had the opportunity to kind of get acquainted with that path like early on. So for the first 2 summers, I ended up doing research with one of my profs, one of my professors at Toronto, and at that point, I greatly appreciated the intellectual freedom that came with working on one problem for several months and bringing it to a conclusive a worthwhile conclusion, essentially. So it was, and I at that point, like after 2 years, going into the industry was a bit of an afterthought for me. I would have much rather just stayed in school and pursued research. But I did apply anyway, and I ended up the projects I kind of worked on both at Google and later Intel involved like a lot of pathfinding, and which bore like a lot of similarities to the academic research I was pursuing. So yeah, at that point, I was fairly certain that that was the route I wanted to go down, and I thought it might be worthwhile for me to kind of get formal training in pursuing research, which is exactly what you get with the what you get with the PhD program. So this was the ideal route for me.
All right. And what about the area of computer science that you're currently working on?
Sure. So my research is broadly speaking in networking, and more specifically, it's at the intersection of networking and architecture. So essentially, network systems, creating or optimizing network systems for performance. So that's the general theme of this area.
Okay.
And the idea is to allow like elastic scaling of the computers that are used in network processing, etc.
All right. Okay. Thank you so much. In 2018, you won the CNIB Prize for Excellence in Accessible Design and Engineering for people who are blind or partially sighted. Can you describe your capstone project briefly?
Sure. So the title of my senior design project was Continuous Real-Time Face Recognition on Commercial Off-the-Shelf or COTS as their known mobile devices.
Okay.
So it's a bit of a mouthful, but essentially we were trying to implement real-time face recognition on regular low to mid-range smartphones, specifically ones that didn't have custom hardware. So like the neural engine that Apple has in its more recent mobile processors. So traditionally, facial recognition or verification systems employ deep neural networks, like especially convolutional neural networks or CNNs. And we've made significant progress in the deep learning space over the last 5 years. So these systems are capable of achieving like remarkable accuracy, like well over 95% on standard data sets. The problem is that mobile GPUs, which are used to compute this workload, or which this computational workload is offloaded to, are significantly worse than those used in state-of-the-art facial recognition systems. So they don't achieve real-time performance. So they can't keep up with the input frame rate, essentially, which is say 30 FPS or 60 FPS in high-end systems. And what that roughly translates to is that the throughput, or the number of images you can process per second, is not consistent with what you get in the video stream. And you can imagine uh, looking into your phone's camera and having to wait like 10 seconds for the thing to respond.
Yeah.
So that's you'd probably not be happy with that.
Yeah.
So on the other hand, these existing facial recognition systems tend to use more like these older techniques, older statistical techniques like eigenfaces or Fisher faces. And these algorithms are like well over 20 years old now. So while they achieve real-time performance, they don't perform well on the accuracy metric. So they don't generalize well to faces outside their training sets, and they also suffer from these other problems, like they're not robust to occlusion. So partially covering their faces, or variability in lighting conditions, and all of these are non-idealities which are characteristic of the mobile space. So essentially, and so this is the other end of the spectrum, which is basically you can imagine a stranger looking into your phone, having it unlock for them instantaneously. So that's no good either. So basically, there's this fundamental trade-off between accuracy and performance, which is characteristic of like these kind of systems. And and the two systems I mentioned earlier, like kind of on both on two ends of the spectrum. So with this project, we were essentially looking to find a reasonable middle ground between accuracy and performance, such that we optimize the accuracy we can achieve while still performing well on the throughput, or like performance metric.
All right.
And essentially, we ended up. So our work was based on these papers published by this group at Oxford. We ended up using what are known as binary feature descriptors in conjunction with like standard supervised machine learning techniques, and that seemed to perform well on standard data sets. And it gave us the kind of real-time performance that we were expecting. So and the use cases we were looking at for this kind of offline mobile-based recognition system were for example, helping Alzheimer's patients make face name associations. So you can imagine a head-mounted display with, where having a person in the frame, like a label shows up. So it kind of helps like catalyze the process of associating like a name with that face, because they see people, but you need to essentially jog the memory as far as recognizing them goes. And the other one, the other kind of use case was in helping blind or partially sighted people recognize people around them. So again, you can imagine a head-mounted display, except that now when you have known persons in the frame, it reads out the name. It reads out like the labels associated with them.
Yeah.
So that was the high-level goal.
Okay, thank you. So you were a software engineering intern at Intel Corporation. What is your advice to juniors who wish to avail such internships in terms of either their profile or interviews?
Honestly, the best advice I think I can give is to just apply. I can't tell you the number of people, and I think I'm guilty of this too, who who kind of put off or altogether skewed applying because they didn't think they were qualified. But and tried as it might sound, you do miss all the shots you don't take. So there's really no reason to not apply. The other thing I think people need to realize about the hiring process in the industry is that it's flawed and most certainly stochastic.
Yeah.
So you might be the best candidate for a job, but it's possible you were turned down because like no human ever read your resume, right?
Yeah.
So that's not something that should that's definitely not something that reflects on you personally, and it's worthwhile to take that in stride.
Okay.
So after that somewhat long-winded rant, I think it's worthwhile to try and demonstrate your interest in when you're drafting your resume. So and what I mean by that is essentially everyone has lists like several programming languages or tool chains that they claim to have knowledge of.
Yeah.
But the way to really demonstrate that is to highlight projects you've worked on in any capacity, so like side projects, and show, kind of explain or describe how you solve like sub problems optimally, or cases where you displayed like managerial skill or stuff like that.
Yeah.
So I think fundamentally the way to demonstrate both like passion and technical competence is through detailing how you solved, how you went about implementing like a system.
Projects and stuff. Basically.
Right, exactly.
All right. Okay.
Yeah.
Okay. Having worked with the Google Android Nearby team and the Google Android Treble team, what were the kinds of projects that you got a chance to explore?
Sure. So I should preface this by saying that Google does something called so prospective Google interns go through a process known as host matching, which is basically a conversation between prospective interns and hosts based on our teams based on mutual interest. So having done research in the first 2 years of undergrad, and specifically in the mobile space, so that essentially summed up my background.
Okay.
So I knew, I was fairly certain that that was those were the two domains I wanted to explore. And I was pretty fortunate in that the first project I worked on, which was on the Android Nearby team,
Okay.
was essentially a research project.
Yeah.
So the Nearby team basically facilitates like interaction. So it's a framework to facilitate interaction between proximate devices using communication channels like Bluetooth, Bluetooth, Wi-Fi, and surprisingly audio. So the project I was working on was an audio-based localization system, which uses like the phone's speaker and mic to perform localization. And the overarching goal of the team as a whole was basically to allow devices to have a contextual understanding of their surroundings.
Okay.
So I guess the way to reason about this is, let's say you're sitting in a house with multiple televisions, and you say, okay, Google, play Game of Thrones. So the device or the assistant, based on context and location, should have should be able to algorithmically figure out that you want to project that stream to the screen in the room you're sitting as opposed to one across the hall. So and my project was a small component of that.
All right. Okay.
so more recently, I was there again this summer in 2018.
Okay.
This time I was working on the Android Project Treble team. So this is, I guess, not as popular because it's not public facing, but this time around, I was interested in exploring uh, in doing compiler related work. Um, so I was working on this tool chain for like a low level language called Heido, or like the hardware abstraction layer interface definition language. So it's like an internal language that Google uses to describe interfaces. And again, while it didn't involve as much research as the one in 2016, it was certainly a good experience in that I got to experience what like the team culture is like, and work with some pretty remarkable people. So I think overall, industry experiences are great to like get some perspective.
Okay. You won the NSERC University of Toronto Excellence Award and the EC Undergraduate Research Fellowship under the guidance of Professor Jonathan Rose. According to you, which aspects of your profile or project contribution stood out while applying for these?
Sure. Um, so I think this alludes to the point I was trying to make earlier about trying to demonstrate like your passion or interest in through your resume or through any written statement essentially. Um, so uh, so so I applied for these fellowships back in my first 2 years of undergrad, and as you can imagine, my resume was sparse, at least to say. So you know, but but I did have the opportunity to work on some interesting research problems as part of course projects, and some of those were, I think, compelling enough that they involved a decent amount of like fact finding and research effort. So I think detailing that experience in my resume was a good way to demonstrate research potential, which is essentially what fellowship applications are really looking for. And that, alongside the fact that the projects that I would work on were also had compelling problem statements, is something that I suppose the committee found interesting.
Okay. I just have
Um,
a small query. Uh, do they
mhm.
also look at publications in in such cases, or is it that they give more weightage to a better, like a very good, impactful project?
So they definitely look at holistically. They would consider things like publications and things that are tangible, like grades essentially. But since this was for an undergraduate fellowship, they probably weren't expecting people to have made substantial contributions in that regard.
Okay.
So what they were more interested in was whether the applicants demonstrated that they would you know uh, they would work on interesting problems and bring them to their logical conclusion.
Okay.
So I think that was the point.
All right.
And I think it's kind of unfortunate that you can't demonstrate like genuine interest through uh, as much as things like uh, as things which are more tangible like grades. But in I think it's just as important to do that, because uh, that's what really differentiates you from other people, because everyone applying for these has the same kind of grades, has the same kind of um, experience in that sense,
Yeah.
but um, uh, interest helps.
All right. Thank you. Okay. So back in 2016, you mentioned that Professor Jonathan Rose had been an inspiration in a University of Toronto news article. That's there online. So yeah. Which aspect of his work interests you?
Excuse me. So, so Professor Rose was my mentor throughout the course of my undergrad, and so he essentially he taught me a foundational programming course in my first year, following which I did research with him for the next 2 years, and he was also instrumental in the whole uh, graduate application process. So, as someone who had a strong affinity for both teaching as well as academic research, I think it was extremely useful to have someone of that stature and like who'd made immense contributions in both regards. So it was useful to have him as a mentor essentially, and I suppose I can say the same about a lot of my undergrad professors, but his teaching style and the kind of work he did. So he was like basically a pioneer in digital logic. So uh, that's uh, in that research field. So it was good to it was useful to do research under him and learn from him. So I guess his style really stuck out.
All right.
Uh-huh.
What were the challenges that you had faced during the PhD application phase?
So I think one of the biggest challenges in applying for grad school in general is just the dearth of like resources which are available for like prospective grad students. And I don't mean like test guides for standardized tests. That's there's way too many of them. Um, the thing I'm alluding to is basically the ability to have 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 someone look at multiple iterations or give you feedback on multiple iterations of your research statement, or kind of help guide your thought process as to what kind of research you'd like to pursue, or help recognize top faculty that you'd like to work with. And as hard as the kind of full-time job search is, I think there's like a certain solace in knowing that everyone is in the same boat. So you're applying for full-time jobs, but so is everyone else. So that's fine. Like it's going to work out. With There's just fewer people who do that when it comes to grad school. So it just feels a little more lonely, I guess. Um, and while eventually it doesn't last for long, so it's a 4-month process that starts in September, and then you're done with, well, it could start earlier, but you're essentially done by December, and then you're waiting on applications. So I guess the other thing is the anxiety associated with hearing back. So as remarkable as all of your referees uh, and your mentors are, professors also they're kind of notorious for not submitting things on time. So there's certain things that just feel out of hand,
All right.
and there's really nothing you can do about it. So
So,
it's just a matter.
okay, I'm just going to ask you a question that's not in the list, and
Sure,
this is just out of interest. How
sure.
many iterations did your statement of purpose or research statement take to
Um,
reach its final form?
uh-huh. Um, so so personally, I find it hard to do a draft of something and then do it over multiple times until I get it right. For me, the writing process is not as fluid. I, I, I feel like compelled to just write the perfect thing the first time. So if you look at my document history for this research statement, I started 9 months before it was due. Did about less than 100 words in the first 8 months, and then I just really had to get down to it. So the deadline was just a forcing function to kind of sit down and write 900 words, or I forget what the limit is, but so but I mean, what would have been useful, for instance, is someone to look over a draft or give you ideas. Um, the you could So one thing people tend to do just naturally, just because there aren't other resources, is that they tend to go to either profs or or upper year grad students or people who are applying alongside them. But that's like all of these things are kind of you're asking people who are busy with their own work, and it's hard to get in a response by the time you have to finish that draft. So it's certainly not ideal.
Yeah. All right. Okay. Being on the Dean's honor list for 8 whole semesters requires unwavering dedication and hard work. What drives you?
Oh, that's very kind of you. I think I think like interest in the material has a lot to do with it. Um, so I think there's like a sense of accomplishment or gratification associated with reading about like a beautiful proof or learning like a novel concept. And I think the good thing about excuse me about this endeavor is that it's like a positive feedback loop. So the more you learn about something, the more you feel compelled to learn about it.
Yeah.
Just because you've made significant progress, and it makes you feel good. So I think so. There's of course like that initial inertia, which is associated with just uh, stopping your favorite TV show and getting down to like read something. But at the end of the day, I think uh, learning something of that sort is like a lot more gratifying than watching a whole season. I've done both, so I can say that for a fact.
Okay. All right. So, which area or subdomain of networking intrigues you?
So I'm particularly interested in the research space at the intersection of networking and architecture. So more broadly, this is network systems. And roughly speaking, the primary goal of such a system is to, or of this research is to basically optimize the performance of systems used in networking. So both the systems as well as applications. And I think this is an exciting space to be in because in recent years the number of user level and data center applications you know has just proliferated. So if you think about 20 years ago, we were looking at fairly simple applications like email, or probably the most sophisticated one was music streaming. But if you look at like a cross-sectional view of the application domain now, like we're doing like we're doing cloud-based like deep learning accelerators, or streaming like petabytes of videos every day. So it's a challenging, and both a challenging and an interesting problem to to ensure that we're capable of like keeping up with the demand. So essentially, we're capable of building systems which have the ability to scale for the next K years essentially. And this is and always has been like an open problem in networking. How do you build robust systems which are capable of achieving high performance? And I think given the number of application drivers, this is a question that's going to be like more important. So building that physical backbone of the internet is going to be a worthwhile endeavor.
All right.
Um, so my current research focuses on what's known as the tail latency or response time in network systems. So so if you imagine visiting a web page containing say 10 large images, it's likely that the first 9 load near instantaneously. So there's no perceptible latency, and unfortunately, that last image is probably going to take several seconds to load. That's the that just happens to be how these systems work. And since you're interested in looking at all 10 of these images, you don't really care what the average or even the median response time is. So you're not interested in how fast the 9 loaded, but you're really going to be waiting for that last image to load. And that time for that pesky last image to load is what's essentially the tail latency. And it just so happens that this is a common problem in latency sensitive applications. So my research, the current research project I'm working on, basically seeks to mitigate this tail latency in such network systems.
All right. Okay. I'll move on to the next question, if that's okay. Okay.
Sure.
So, a lot of your college projects find their application in the healthcare sector. Is there any specific reason for choosing such projects? And I think a while ago you spoke about the facial recognition project for Alzheimer's disease. So,
Uh-huh. Right. I was just going to say, I think that's really perceptive of you. To be honest, I didn't notice that until it was essentially in retrospect that I found that a lot of these have to do with healthcare.
yeah.
And to be honest, it's probably no coincidence, because the first two research projects I worked on were essentially in the research space at the intersection of mobile computing and 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 medicine. So, for instance, the first project I worked on was a a mobile application to quantitatively measure balance. And the overarching goal was to kind of automate certain aspects of ankle-related physiotherapy. So, physiotherapy is an expensive process, and it's not accessible to everyone. And it also happens to be an integral part of rehabilitation for people who've suffered ankle injuries. So, given these facts, it kind of made sense to explore how to do this algorithmically using using a smartphone application, which runs aboard commercial off-the-shelf devices. So so that was the first one, and then along similar lines was the I guess in that space was the second project, which explored a mobile-based eye tracking system. And the goal of this was, again, like it had applications in both like basically diagnosing like neurological conditions, or rather psychological conditions, and also ophthalmology. So, for instance, recognizing whether people were afflicted with certain, like, degenerative eye diseases, essentially.
Okay.
So, and the theme of this research was essentially automation of medicine. And it was somewhere around this time that I realized like just how important medicine was as an application driver for like the technologies we use now. So I think that kind of motivated the the systems we chose to implement for future. I chose to implement for future projects. So right. So I think it's one of those domains where a small technological advancement basically has the ability to make significant improvement in people's lives. So large positive impact, basically. So that was I did appreciate the theme of that research.
Okay. And this is just out of inquisitiveness. Did your professor, Jonathan Rose, also work in this area, like healthcare?
Uh-huh.
He did?
So he did actually. So roughly 2.5 decades ago, he was he he did significant work in the FPGA domain. So FPGAs are this family of programmable, highly parallel devices, and he worked on like tool chains and that architecture. But more recently, he made the transition from hardware to software, and it was I suppose for similar reasons that I just described. Like he found these applications compelling.
Okay.
So the whole, the automation of medicine was really like his is now the theme of his research,
Okay.
and the the projects I did with him were, both in that domain.
Okay. It's wonderful to hear about your projects. I mean, they're really impactful. So,
Oh, thank you.
what hobbies do you pursue during your free time?
That's a good one. So I think this is essentially the first time I've lived alone per se. So I'm still trying to figure out how to optimize my time, the time I spend doing chores.
Okay.
So I'm not quite there yet, but so when when I am done with them, I guess um, I I like to, I like to go like ice skating or skiing, or yeah. So definitely, there's always, something good on Netflix. So if it's an interesting show, we're definitely more than happy to watch that.
Okay.
And also, if there's so reading wise, I think, if I find like a good book on either philosophy or science fiction, those always appeal to me. More generally, I think it's worthwhile as like a grad student to, invest in time like interacting with others, because it's easy to kind of just be holed in and just, uh, continue, well, not working on the research, but it's easy to become like insular in that, you don't talk to people outside your domain. So, this is like literally your only focus. So I think it's worthwhile to socialize and, play, attend board game nights, and, talk to people outside of CS.
All
So
right.
that's definitely something I enjoy doing too.
What is
Sure.
a normal day in the life of a CMU PhD student like?
Um, so specifically with the PhD program at CMU, uh, there's there's not a lot of focus on courses, because, the idea is that people have been spending the past like K years trying to optimize for grades, which is the exact opposite of what they want people to do. So instead, you take a few courses. So you take 6 courses through the course of your PhD, which is typically 5 or 6 years, and you pace them out, however you want. And the idea is you spend at least 50% of your time working on your research project.
Okay.
So for me, I have one class this semester, which means that you know, there's 2 days where I have class at 10:30 in the morning. But besides that, the remainder of my time is spent uh, either writing some test bench, or like evaluating my design, or just working on conceptual problems. And that's always interspersed with like random meetings uh, with either your research group or your advisor. And yeah, and occasionally, they have like weekly lunches for people to attend presentations. So you sit in on other people's presentations and hear what they're working on.
Okay.
Um, and beyond that, there's board games night on Tuesdays. So that's one of the
Oh,
one
wow.
of the
Okay.
avenues to kind of
Okay.
interact with other folks.
Okay. And
So
do the courses have exams or projects, or does it vary? I mean, for the
yeah, so it's
PhD program,
uh
for the PhD
so
program, yeah.
right. So they're just like regular courses, but so I know some schools have essentially you need they do want you to focus on your courses for whatever reason. So in that to be in good academic standing, you need to get like an A- or something. But since that's really uh, not the way they intend people to spend their time, you do have projects and regular coursework like homeworks, assignments, exams, etc. But the courses you take are just for credit. So you don't actually you're not assigned a grade essentially.
Okay.
That alleviates a lot of the burden as far as like coursework goes.
Okay.
So if you have like if you have a research deadline and you have a project deadline for a course, like there's no question what where priority is.
All right. Okay. All right. I think I've covered all the questions, Nirav.